Alright, suppose we have a piecewise defined function called g with these characteristics about it. Let's do some limit expressions here, shall we? So part A. So what are we going to approach? We're approaching 3 from the left-hand side, right? Because this means 3 from the left, this means 3 from the right. So give me an example of a number that approaches 3 from the left. Well, go to the number line. So the number line, of course, let's say I just go over here. Let's say that this is 3, but I must approach it from the left-hand side. So I'm approaching 3 from the left. Let's say I make a pit stop right here. What is the possible value for that number? Well, how about like 2.99, okay? I can get much closer to 3 than 2.99, but let's just stop there. Now, 2.99. Let me ignore this here. 2.99. Does that satisfy the top, middle, or bottom inequality? It cannot work for more than one spot. It can only work at one location. So 2.99, is it greater than 3? If I were to plug in this number here, is it greater than 3? Obviously not. Is 2.99 less than or equal to -2? Of course not. So 2.99 safely lives somewhere in between here, which means that we must go to this middle row and do our math in that location. So now, the purpose of this symbol is really just to make your selection. Once you've selected where you're going, you can pretty much ignore that symbol and just play with 3. So we've selected the middle row. So now take 3 and essentially plug it in for x there. So what's 3 cubed? 3 times 3 times 3, which is 27, plus 1 is, of course, 28. Done. How about here? 3 from the right. What's an example of 3 approached from the right? Well, let's approach 3 from the right. Consider this value here, which we can call that 3.01. Now 3.01, does it satisfy this, this, or that? Well, clearly it satisfies this inequality here. So we are accessing this bottom row of values, of items. So now we're plugging in 3. But notice there's no input for 3. It doesn't matter what you plug in. You get back a constant value every time of -7. Okay? What about down here? Notice that here we're just approaching 3 overall, which means that you're approaching 3 from both directions. And we actually already did that. We approached 3 from the left and we approached 3 from the right. And notice that in both cases, the limit values were in disagreement. They are not the same. So overall, if you approach 3, I don't know if I should go to this one or to this one. I'm confused. So for that reason, the limit is set to essentially not exist. It would only exist if these were the exact same quantity. Consider this one here. We're approaching -2 from the left-hand side. What is an example of -2 from the left? Well, maybe this number here, which has a possible value of -2.01. Now, does this satisfy the top, middle, or bottom inequality? By observation, it satisfies the top inequality. So we can now take essentially just -2 and substitute it in here, so that 5 minus 2 times -2 results in 9. Now, how about some good old evaluations? See, these were limit expressions. This is not. This is just an evaluation. So this is saying take 1 and just plug it into G. Well, make a decision. 1, does it satisfy top, middle, or bottom inequality? Well, 1 is safely found somewhere in between here. So we are accessing this middle row of information. So now take 1 and plug it in for x as your input here. So that 1 cubed is just 1 times 1 times 1, which is 1 plus 1 is 2. Now how about g of pi? So you don't have to think trigonometry here. Pi is, it has an approximate value of 3.1415 and so on. So 3.1415, does it satisfy the top, middle, or bottom inequality? It satisfies this. So we are to take pi and to plug it into here for the input, but there is no input. It's a mere constant -7 as your output.